Good day, everyone. I am Claire Marie Llamas, and I would like to present to you the effects of energy expenditure on the mental fatigue of construction workers. I co-wrote this paper with Maria Janice J. Gumasing and Sarina Ann A. Martin. We can all agree that the construction industry is one of the biggest industries in the world. Due to the rise of construction industry, the number of employees in the workforce also accelerates. As a matter of fact, in the United States alone, approximately 10.3 million people are part of the construction workforce in 2016. Given that, we really wanted to focus on our subject matter, which are construction workers, especially in the Philippine settings. Here are usual discussion points in health and safety risks in the construction industry. First is harsh and dangerous environments, which leads to poor judgment and quality of work, reduced productivity, and increased risk of accident. Also, the construction industry can be physically demanding and have physically demanding tasks, which usually includes awkward postures, excessive force, repetitive actions, and excessive energy expenditures. And lastly, we would like to highlight fatigue. The impact of fatigue is likely to be more serious under the construction environment, which is usually regarded as dynamic and risky. It was revealed that 20 to 40% of different craft workers on a construction site routinely exceeded generally accepted physiological thresholds for manual work, leading to fatigue. So, what is fatigue? Fatigue is a state of physical and mental exhaustion. In many industries, fatigue leads to overall decrease in productivity. There are two types of fatigue. One is mental fatigue, while the other is physical fatigue. Physical fatigue is the transient ability of muscles to maintain optimal physical performance, while mental fatigue is a transient decrease in maximal cognitive performance resulting from prolonged periods of cognitive activity. In 2003, according to Strasser, the assessment of workers' physiological conditions is a crucial prerequisite in every ergonomic study. Numerous techniques are available to assess work physiological demands of construction workers, which were used in previous studies such as questionnaires, oxygen consumptions, and heart rate monitoring. However, right now, there are no published studies, most especially in the Philippine setting, that tackles the relationship of occupational risks in terms of mental fatigue to the physiological demands of work depending on various construction trades such as plumbing, laborers, masons, carpenters, and steelmen. They usually involve only a specific or certain task or job type. For instance, in 2013, a study by Yi on rebar workers while in 2017, a study on specific lifting tasks by Antwi Afariar were published. Given all those, as researchers, we wanted to determine the significant factors that affect mental fatigue experienced by the workers using physiological measures. This is needed in order for us to design a work rest schedule to adjust the physical workload of workers to prevent overstrain, fatigue, injuries, as well as possible accidents in the workplace. So, how did we come up with this research? First, we prepared our sample size. We decided to conduct a survey on 25 workers under different construction trades, 5 to be exact, which are plumbers, laborers, masons, carpenter, and steelmen. We conducted an experiment on 5 of each trade, so 25 workers in total. We omitted the other trades such as foreman and timekeeper because they were only assigned with simpler tasks and it might skew the study that we wanted to conduct. So, after choosing our sample, we conducted a thorough investigation and analysis from previous studies and researches, And then we prepared survey forms and questionnaires to the construction workers, managers, healthcare practitioners, and similar stakeholders in order to determine the factors that will be considered in the study. Next was an on-site observation during their tasks so that we will be able to assess the fatigue-related risks. All the data were gathered using apparatuses, devices, and instrumentation. A notable device was the fitness tracker, which was used to obtain real-time data for height rate and activity metabolic rate. After that, in order to measure the mental fatigue level of the respondents, we used the real-world reaction time software, which was developed to measure the average length of time for an individual to respond to visual or auditory stimulus. The test represents the alertness and motor speed of an individual and will be used to represent the level of mental fatigue of the respondents, as it was used in previous studies as well. Two types of reaction time were considered. First was the simple reaction time, and the second is the choice reaction time. Simple reaction time is measured to determine the response time of an individual when performing cognitive tasks without decision making, while CRT or choice reaction time is the other way around, which is a more complex test that measures the capability of an individual to respond when choice is presented. In order to determine which among the contributing factors like age, body mass index, heart rate, and activity metabolic rate have a significant difference among different construction trades, the researchers had to use one-way ANOVA at the level of significance of 0.05%. Next, correlation analysis was also used to determine the strength of a relationship between the factors considered in the study to the mental fatigue of the respondents. To further illustrate this relationship, as mentioned, the researchers or we also use multiple regression analysis. After conducting data gathering and statistical analysis, showing on the screen is a sample ANOVA result for AMR. The results of ANOVA indicate that there is no significant difference in the AMR, heart rate, age, and BMI among the 5 construction trades. Next is the result for correlation analysis. This result explains that as each factor increases, the reaction time or mental fatigue of the worker also increases, as the factor and mental fatigue are directly proportional with each other for both SRT and CRT. And lastly, as mentioned, to further illustrate the relationship of the factors to the mental fatigue of workers, the researchers performed the multiple regression analysis. 2 regression models were developed for the study. The first model is for the SRT or simple reaction time, and the other is for CRT or choice reaction time. The predictors considered for the both models are the physiological measures for energy expenditure such as AMR, heart rate, age, and BMI. The result of regression models prove that all factors AMR, HR, age, and BMI significantly affects the SRT and CRT of the respondents, having p-values of less than 0.05 and model accuracy of adjusted R-squared values at 88.48% or 88% and 90.48% respectively. Ultimately, the researchers wanted to develop a work-rest schedule, and in order to come up with that, first, they calculated the maximum allowable work duration. And next, they used Monte Carlo simulation to replicate the observed data. And lastly, they come up with optimal work rest schedule. So how did we compute for the maximum allowable work duration? In a study conducted by Wu in 2001, this equation was used and it was able to determine the MAWD to be imposed on workers doing high-intensity work similar to that of the tasks of the construction workers. Several factors such as oxygen consumption, self-reported exercise, and the likes were used in this computation. In order to attain a more accurate result, the researchers opted to use Monte Carlo simulation model, which is a technique that produces different randomized situations that will help in determining solutions for a given problem. The model used was derived from a study conducted by Yi and Chan in 2013, which has a similar objective with the study to be able to create an optimal work rest schedule for workers in the construction industry. As shown in the screen, a sample result for the first 5 runs of the Monte Carlo simulation was shown. So there are 3 random numbers produced to generate 9,125 runs and approximate a year worth of data for all 25 workers. After the simulation run and considering several factors such as the maximum allowable work duration, age of the construction workers, and number of rest period, the researchers came up with an optimal work rest schedule which is illustrated in the screen. So the work duration runs for 120 minutes and the worker is then given the chance to replenish for 20 minutes and regain his optimal MAWD by 84%. So this duration for 120 minutes and a 20-minute break in between, as well as a 110-minute work right after, is then replicated on the afternoon shift or the after lunch shift of the worker. As shown in the study, it has been revealed that the workers in the construction site routinely exceed generally accepted physiological thresholds for manual work, leading to fatigue. It was evident on the factors gathered such as the AMR, heart rate, age, and BMI. The results of the statistical analysis such as correlation and regression model prove that the factors considered in the study have significant effect on the mental fatigue using the SRT and CRT tests. Considering results of the study, the researchers were able to design an optimal work rest schedule for the construction model workers using Monte Carlo simulation model. Through this method, the researchers were able to determine the MAWD or the maximum allowable work duration for the workers and compute the optimal rest period to lessen the fatigue experienced by the workers in different construction trades. I do hope that this presentation enlightened you on our paper, which is the effects of energy expenditures on the mental fatigue of construction workers. Thank you for listening.